Let's be honest, when I say nuclear explosion, what's the first thing that pops into your head? It's that image, right? The mushroom cloud. It is an absolute icon of power, of destruction, but it's also, really misunderstood. So today we're going to break it all down, not just what we see, but maybe more importantly, the invisible danger that follows.
Yeah, this one image, it's been seared into our collective consciousness. But behind that terrifying beauty, there's this incredibly complex series of physical events going on. To really, truly get what's happening, we've got to look a lot closer.
Now, this might sound a little weird, but stick with me on this. The way a nuclear blast just lights up everything around it, creating light, shadow, depth, it's actually a lot like how a cinematographer lights a movie set. It's all about controlling what you, the audience, can see. Except in this case, the director is physics itself, and the scene is one of just unimaginable power.
So these are the basic principles, right? The building blocks filmmakers use to create a mood, to make a flat, two-dimensional image feel real and three-dimensional. And believe it or not, a nuclear blast does every single one of these things in just a matter of seconds. It all starts here. This is step one, the key light. And then this show, the star is the fireball. It's this brilliant, glowing bubble of superheated air and vaporized stuff, and it's so unbelievably bright that it literally defines the entire visual landscape of the explosion. Okay, so you've got your light. What's next? You need shadows to give it some depth. As that gigantic fireball shoots upward like a monstrous hot air balloon, it creates this powerful updraft, just sucking dust and debris and everything else off the ground into its base. And that forms the stem. It blocks the intense light from behind it, and just like in a movie, that contrast, that play between light and dark, is what gives the whole thing that incredible three-dimensional look.
And for the grand finale, as the fireball gets higher and higher into the colder parts of the atmosphere, it starts to cool off. All that vaporized material, all that water vapor, it condenses and spreads out, and voila! You get the iconic puffy head of the mushroom. Our cinematic masterpiece is complete.
Now, here's where it gets really interesting. Our eyes can play tricks on us, because not every cloud that looks like a mushroom cloud is actually formed in the same way. The image itself can be a kind of illusion.
Let's look at a classic example here, the famous Crossroads Baker test back in 1946. This thing was detonated 90 feet underwater. So what looks like a stem, that's actually a hollow pillar of water getting blasted into the sky. And the head, that's just a temporary cloud of condensed moisture that pretty much vanished in seconds. It looks the part, but it's really a visual echo, not a true mushroom cloud.
And it gets even weirder because the atmosphere itself starts creating its own bizarre special effects. You'd see these rings of vapor form in the humid air of the South Pacific. Some of the huge megaton blasts pushed moisture so high it would literally freeze into ice caps at the top of the cloud. Sometimes you'd even see these weird cone-shaped skirts or bells of condensation falling down along the stem. Oh, and my favorite? The rope tricks, where the metal guy wires holding up a test tower would instantly vaporize into glowing strands of plasma. Just wild.
But for all this incredible, terrifying visual spectacle we've just been talking about, the most significant part of the story is the part you can't see at all. We've been looking at the light, the shadows, the shapes, but the real, lasting danger lies in the invisible aftermath.
And that is nuclear fallout. We're talking about the cocktail of radioactive particles created by the blast. After being shot up into the atmosphere, this stuff doesn't just, disappear. It has to come down somewhere.
And not all fallout is created equal. You've basically got two main kinds. There's local fallout, which comes from explosions on or near the surface that kick up a ton of dirt and debris. These are heavy, super radioactive particles that fall back to Earth pretty quickly, within a day, creating these hot spots of intense contamination. But then there's global fallout. This comes from high-altitude bursts, and it creates these really fine particles that can just drift around in the stratosphere for months, even years, spreading a thin layer of radiation across the entire planet.
So how does this poison actually spread? Well, the process is horrifyingly simple. The blast vaporizes everything at ground zero. That material gets sucked up into the radioactive cloud. The wind takes over, carrying it for hundreds, maybe thousands of miles. And eventually, those radioactive particles fall back down, poisoning everything they touch.
To get a sense of the scale here, let's just look at the Chernobyl disaster in 1986. Now, it wasn't a bomb, but that explosion released a massive amount of radioactive material.
The fallout contaminated over 20,000 square kilometers of land in Ukraine and Belarus alone. That is an area almost the size of the state of New Jersey.
And this contamination wasn't just some generic radiation. No, it was this nasty cocktail of specific, really dangerous elements. Things like strontium-90, which our bodies mistake for calcium, so it gets into our bones, and cesium, which spreads all throughout the body's soft tissues. This is the bad stuff.
The immediate impact on the local environment was, well, it was catastrophic. The nearby pine forest died and turned this eerie ginger color. They're now called the red forest. Animal populations just crashed. Livestock just a few miles away got sick and died. The soil itself was so poisoned it couldn't support new life.
And this is where the timescale just becomes absolutely staggering. The blast itself is over in a flash. The light is gone in seconds. But the fallout remains. Iodine-131, that's dangerous for weeks. Strontium-90 and cesium-137, they'll contaminate the environment for generations. And plutonium-239, its radioactive legacy will last for 24,000 years. That's longer than all of recorded human history.
And here's the final insidious step. The fallout doesn't just sit on the ground. It gets absorbed by plants, which are then eaten by animals, and it just works its way up the food chain. That invisible external threat becomes a silent internal one.
And let's be perfectly clear, this is a global problem. That radioactive cloud from Chernobyl, it didn't need a passport. It was tracked across the entire northern hemisphere. Sheep farms in the UK had to be monitored for decades. Fallout does not respect borders.
So we come all the way back to that iconic image, the mushroom cloud. We can analyze its shape, its light, its shadows, but now, knowing what we know about the invisible poison, the poisoned earth, a legacy that will outlast civilizations, that image isn't just a spectacle anymore, is it?